Hi everyone, this video is on exercise 13G question 5. So we have this curve and also the line y is equal to 12. And in part A, we want to find the coordinates of the point A where the line meets the curve. And finally in part B, we want to find the area, which is the yellow region. Okay, so as usual, we first find the point of intersection by setting the equation of the curve equal to the equation of the line. So we have x times 4 plus x is equal to 12, and then we get 4x plus x squared minus 12 is equal to 0. And when we factorize this, we get x plus 6 times x minus 2 is equal to 0, which means the roots are minus 6 and the other root is plus 2. Okay, so here a is obviously positive, so a has coordinates 2 and 12, so 12 is just its y coordinate. Right, part B is the interesting part. So we want to find the area of R, but we should be very careful because this diagram is different to the previous questions that we've had. So we just need to go back and think about the meaning of area under the curve first, and then we can then solve the question. So if we want to find or actually integrate x times 4 plus x, which is just the curve, so that the integral is going to give us the area bounded by the x-axis and under the curve basically. So it's going to give us the area of the blue regions, right? And obviously this side, the left side, is not going to help us in any way. So this helps us to understand that when we want to integrate x times 4 plus x, the lowest limit, the lower limit of the integral is going to be 0, because anything below 0 is not going to help us, right? Because that's going to give us the area of this region, which is not part of the question. So this helps us to understand what's the lower limit of the integral. It's 0. And the upper limit is very clear because the upper limit is obviously where we have the point A, which here has x coordinate 2. So the upper limit is 2. So one of the integrals is x times 4 plus x dx, and the limits are 0 and 2. And the other integral is the line. So again, we need to be careful in terms of choosing the limits for the line, because if we choose any limit below 0, the line is going to give us any the area of this region that is bounded by the line and the x-axis. So it's going to give us this region, the area of this region, if we choose limits that are less than 0. Again, this is irrelevant because what we only care about is this side, which again the lowest limit is 0. So the lower limit of the integral is 0, and the upper limit is going to be this part, which is just 2 basically. So therefore in terms of the line, we have the integral of 12, but that's between 0 and 2, because again anything before 0 is just going to give us the area of this irrelevant part, and we only want this side between 0 and 2. So that's going to help us. Now let's tidy up the diagram and show you exactly how should we set up the integral then, because right now we have we know what are the limits, but what about the integral? So okay, if you pay attention, you'll see that when we find this integral, so the area under the line and bounded by the x-axis between 0 and 2, so that's going to give us this sort of rectangular region, the area of this rectangular region. But the problem is that we only want the yellow region, not the entire of rectangular region. But the interesting thing is that the area of the curve is going to be for this part. So just to shade that with green, the area of the curve between 0 and 2 is exactly this part. So the part that we don't want. So it simply means that this area of the under the line gives us the total area basically, and then the curve gives us the unwanted area. So we just need to do a subtraction, and if we do the subtraction, we'll get the area of the region that we want, which is R. So again, if you look at the diagram carefully, the curve gives you the area of here, the line gives you the total area, so that's why we subtract the area that curve gives us from the, basically we take that away from the total to get the area of the region R. So therefore it's just a simple integral of 12 dx minus x times 4 plus x, but as we have discussed before, since the limits are the same and we are both integrating with respect to x, we can combine the integrals. So we have 0 to 12 minus 4x minus x squared dx, and then integrating, so we get 12x minus 2x squared minus the third x cubed, and the limits are 2 and 0, so we just substitute 2 and then take away 0 substituted, but that's obviously 0. So once we substitute 2 here, we'll get 40 over 3, and this is the area of R. Just a quick something very quick here is that we could have also, because of the diagram, in order to find the area basically of this rectangular region, just find the area of the rectangle, because we could have just used width times length, which is 2 times 12, which would give us 24. And if you look at this integral, which is basically integrating that region that is a rectangular region, this integral is also equal to 24. So we could have also used that method, but I just stick with integrals.